Derek Stone. I'm with Lucky Peak Power Plant. We are a small power plant located in Boise, Idaho, or just 10 miles out of Boise, Idaho. We started our integration project about a little over 2 years ago. So some of the topics I'm going to cover are who we are. I'm going to talk about our top-down, bottom-up approach to integration. I'm also going to cover how we laid down the groundwork for integrating into kind of a legacy plant, an old plant that was finished in '88 and hasn't had a whole lot of improvements done to it since then. I'm also going to talk about what steps we went through to integrate, show you some of the concepts we came up with to improve getting to those end devices and applying them to be able to do better operations. One of the big things about our project was that our alarming was terrible. So we had a ton of truncated alarms. And so that was a big part of our project to be able to go in and talk to those end devices and separate them instead of them all being together. And then the other thing is by having those end devices and having that real-time value, how do we display that data to the people that need it, the end users? And then lastly, I'll talk about, even though we're still in the middle, or I shouldn't even say the middle, we're still at the very beginning of our project or our integration process. What are the hurdles that we're looking at getting to and overcoming as we move forward. So like I said, we're a hydroelectric power plant. We are owned by the Boise CUNA Irrigation District. Our main role as far as a hydro plant is to maintain the flow of the river. Most power plants that they ramp up and they provide peak power to the end users. Our main objective is to maintain river flow. If they say this is the amount of flow that you're going to put down the river, that's what we generate with. There are certain situations where because a lot of our resources is in the mountains, if we are lucky enough to get an abundant amount of snow, then we might also do flood control. And that was one of the main reasons why the dam was actually put in before the power plant was for flood control. So we also help out with that. Our plant consists of 3 generators. Total, we produce about 101 megawatts if we're allowed to put that much water down the river. The unique thing about Lucky Peak and in an integration process, when you think about who your stakeholders are, is we're actually managed and operated by Seattle City Light. So when you're talking about all right, who do you got to get the answers from to go ahead and move forward, we have two stakeholders that we got to be able to appease. And so before I start talking about the top-down part of this integration process, I probably need to give you a little context of how this kind of actually started. So I've only been at the power plant for about almost close to 6 years, 5.5 years. We had an event happen where there was a situation on the transmission line. It opened up the breakers in the outside. And so basically, just like everything's supposed to happen, breakers are supposed to open for the transformers, things are supposed to start shutting down. But as it did that, we started noticing that there were some cascading or dominoing effects that because we don't have any visibility in the end devices, we couldn't really give the answers to. We don't know why it happened. Was it operator? Was it an end device? Was it a piece of equipment? And so at that time, our generation supervisor, who was almost the extent of the birth of the plant from '88 on, I had a conversation with him about trying to figure out why and or how can we find out what causes? How can we go and solve that solution, take care of that problem? And what I told him is if we had some visibility of that stuff, that we could probably have a better idea what's going on. And so that kind of is what kickstarted us to start looking into integrating the plant. And so it's a unique dynamic of having someone who's been there a while, that knows a lot of the history of the plant, but also holds a lot of that tribal knowledge that isn't really passed down below. So part of getting that project approved, when you look from I was thinking, okay, we were going to do this integration project. From the top down, I'm going to get some of these things that are going to be really key to my success for the project. And some of those you'd think that I'd get some standards from the top that they'd already know like what kind of things we want to do to create a standard for integration. And also, project management accountability. Being involved in a 10-year plan that the integration process would happen within. And then if they're approving it from the top, you automatically think that everybody's on board, right? So, sorry, that was a joke. So one of the things I noticed from the top, and a lot of people that have been there a while, the reason why it's legacy equipment is because there's not a lot of subject matter experts involved there. So, that was like one of the things that I noticed after already getting the project approved. How do I deal with that? And in turn with that, it entailed a lot of scope creep as far as my project goes. Everybody's like, oh, he's got a project. Hey, do this. It's like, whoa, whoa, whoa. That's not part of it. That's something completely different. And along with that, we had a lot of missed opportunities to integrate, which in turn led to a lot of pushback for the project. So having that integration. So as I saw that there, how do I get help from the top? I was like, all right, so maybe I got to do this from the bottom. So I thought, okay, well, it's been approved. I should have that support from the stakeholders, right? I should have buy-in from the field. I mean, I work with these guys. Everybody else sees the same problems I do. We talk about it all the time. We are the end users. How do we make that happen? Part of the things that was actually a good part is that we did have project requirements. Some of those are that the operators were going to be the designers. They're going to give the input for what we want to see from an end device, and as well as that we're going to do high performance HMI. And then lastly, the guarantee that we have subject matter experts involved with the design process and getting to those end devices. So as I was thinking about this and I started working towards those goals, I noticed that there was conflicting levels of support, both the top and the bottom end. So it's like, oh man, how am I going to accomplish any kind of success? So along with that, it was really easy to lose sight, for everybody to lose sight exactly what our requirements were for doing this project. Like, why are we doing this? Well, we had an event. We can't explain it. What are the requirements that you were going to do? Oh, well, we're going to have the end users do this, right? They're going to tell us what how to build this, how to make it effective, and push that forward. So shortly after I had the project approved, and we already knew this, that the existing generation supervisor ended up retiring. So in one aspect, it was hard to lose that kind of tribal knowledge. On the other hand, the person that filled his shoes had a lot more experience with seeing real-time data from a utility generating plant. And so what we decided to do after having a few conversations about how we're going to continue to integrate is that we decided that we actually need to come together. So we developed a plan to be able to tie the subject matter expert into our 10-year plan. We're integrating those processes and our procedures for the operators to be able to follow. And at some point, we'll hopefully get to that 100% people on board. If we have that, then it makes it easier to know if you're getting the success, and if you're not getting the success, what you got to do to get there. And still maintaining those requirements. I think one of the best things about the approval of the project was that the operators are going to be the ones that are going to be part of that design process. So as you know, utility has a lot of requirements. So that made it very difficult at the very get-go. And so one of the things we decided right out of the gate is like, look, let's just create an isolated network. We don't have to worry about anybody getting in. And what we're going to do is we're going to design it in a way that we'll have visibility all throughout the inside of the plant. So nobody can get into it from the outside. And so that's the steps that we took. We needed to make sure that it was going to be accessible, especially for all the end devices that we have throughout the plant that we wanted to upgrade and bring to the operator desk. The other thing, if you think about legacy, is about how old it is. So when you go into some of these plants that have had high turnover for 30 years, if you see the picture on the left, you run into things like that. And, you're like, and when you look at it, you're like, oh, we're not going to fit anything into there. So part of the task before we even started getting to the end devices is we knew we needed to do some housekeeping. And so pretty much everything on the left fit into one terminal strip at the very top of the screen on the right. And so that allowed room for all the relays, all the I/O, and a couple other things that it did for us. By going through those circuits, we were able to relabel, redocument, and part of that process, it cleaned up a lot of things for us. We found that we had some documentation. Our prints were quite updated from other red lines from previous people. And so we were able to go ahead before we actually started to integrate to say, all right, turn everything back on, failure. That we actually were able to take care of those issues before we even started that process. So when we look at the integration process of what we have basically, I look at it as we have 5 assets. We have three generators, we have our transformers, and we have our station service, which is our 125 volt DC. So basically, when we have an issue of one of those, they'll basically send a signal to a light box that says, hey, this is the problem, here's your problem. And basically our PLCs, all it does is do flow control. It tells the units, hey, a little bit more flow, a little less flow. And along with that, we do have relay protection through our RTAC, which basically protects all 3 units. And because we're legacy, part of that process is when we have something happen with the light box or we have a problem with megawatts, we have an operator come out. He figures out the coordinates on the light box. He writes down that number even though it says what it's supposed to be. Goes to a book, thumbs through the book, A7, sink my battleship. And then you figure out what 20 devices it might be. So then you have to go downstairs and try to troubleshoot that. So the process that we're getting to is that we want to be able to connect to all our end devices. So we established our network ring, and we wanted a central location that we can bring everything to that we can then direct it straight to our operator desk. So that way the operator has complete visibility of everything going on in the plant. He doesn't have to worry about traveling through the plant to go look and see what a device says manually because everything is literally analog. And so that's the goal. That's where we're trying to get to. So one of the hardest things was to figure out what SCADA system we wanted to use to be able to pull all those devices into. And so we wanted to stay open. We have a lot of legacy equipment. We didn't want to be locked down to just one vendor. We just had too many things in play that it didn't allow us to do that. And so we ended up, we needed to find something that would allow us to prioritize our data and be able to deal with our alarming so we won't have the alarm drowning. Some of you might know the terms of alarm drowning or flooding or maybe fatigue. So most people, I think PC is the PC word for alarm drowning is fatigue, right? But in hydro, we use flooding and drowning, so because we have the water. So the other thing we wanted to do is we wanted to build the trends for a purpose, not for practice. We do enough practice of that when we do our time-based management where we take our clipboard, we walk around and write the data down, and then we throw it on the shelf and we wait until 4 o'clock again to do it again. And we also wanted to make the data accessible. And so in this picture here, it kind of gives you an idea of like where we are right now in our control room. So we have 4 monitors that basically are for the operator to see all the devices that we have currently. If you look directly above the 4 monitors, you can see the light box. And it's basically nothing's lit, it's not telling you anything. It's just telling you that there's nothing abnormal right now. The big monitor that you see in the upper left-hand corner is our new annunciator monitor, which is a 55-inch touchscreen that we did, which not only just supplies the alarming capabilities for just that unit, but it also, instead of just being something that's just blank and doesn't give you any information, we're also using it to be kind of like at a glance visualization of what's going on that unit. And so we wrote a program for it to start cycling screens as there's no activity for that monitor. And so that way when the operators are going in and out of the control room, as they walk through, they can see what's going on. They can continue on with their business if they don't see anything that's happening. And so that allowed a lot of freedom for the operators to continue on with the other things that they were responsible for without having to be locked down to a chair all the time. So back to alarming real quick, because it's a passion of mine. This is kind of an example of some of the things that we were dealing with. So as you can see in the middle, we have a turbine bearing oil temperature level. Sure, okay. So I'm not sure what I'm supposed to go look at with that. Levels or temperatures? And along with our excitation abnormal, or we call it abnormal, we had 20 different alarms that would come in, or could come in, and they would just bring that one light box to light up and tell you have an issue. And that makes it really hard to go down and troubleshoot. Like, where do I go and look for that? Is it all on the same level? Is it in the same piece of equipment? Even our documentation in our books didn't tell us that. And so there was a lot of time spent trying to figure out what is the actual problem and how do we fix it. So one of the other things that we did with the alarming is we wanted to, as you can see here on the far right, I started creating alarm templates. So the idea that we came up with is that we're going to kind of apply ASA 95 kind of unified namespace hierarchy of how we were going to deal with our stuff. So we have our assets, we have our systems, and then we have our devices. And so as we look at the templates for our devices, we are separating them into under our systems, and we bring a template up for that system. And as an alarm comes in, the actual device will light up red, letting the operator know exactly what device under that system is actually active. And we also are providing the tree of kind of like an electrical schematic of all the devices that are below that before it gets to its end device of maybe possibly shutting down. And so there's a couple of reasons why we wanted to do that. Sometimes there's a little bit of logic involved with some of those end devices. And so not only can you see that the device came in, but you can see where in that logic that circuit is. Is it a timer? Are we like 5 minutes out before we shut down? Is it possible to stop that? Can we go fix something real quick? And also, if you have something come up and you know it's supposed to go straight to a shutdown and it's not lighting up and it's not shutting down, you know that you have a fault in your system. So having that complete visibility over the entire circuit was important for us. So when we talk about trending, there's 2 points of view to look at trending. There's either you're going to do time-based management or you're going to do value-based management. And so we do a lot of time-based management with just the clipboards walking around, collecting data, and then we put it on a clipboard and we kind of forget about it. The whole idea is that we wanted to do with our value-based data is that we wanted to make sure that it's providing the visibility that we need when nobody's writing anything down. And I put this image up of a situation we had when we were doing some changes in our generation. And what we have is, at the top we have our temperatures, at the bottom we have the cooling water for our temperatures, and in the middle we have our generation. And so we noticed that when we changed in our generation, because of the physics through the penstock and our cooling system, it changed the cooling water when we made that change, which we never would have saw because we only go at 4 o'clock to write this number down. But until we started getting that real-time data, we started noticing that, hey, we're affecting some of our systems regardless if we know it or not. And so that became very important for our operators to start thinking about, like, hey, I got to kind of change how I work. The other thing we wanted to do from a high performance standpoint is be able to create that visibility at a glance. And so by creating some custom templates, we were able to make it so that as we were showing just temperatures, that they're unique in the aspect that the operators can just look over them real quick, say, hey, I'm in the parameters that I need to be, I can move on. I can go to the next set of temperatures. I can see that they're all where they need to be, I can move on, I can go to the next set. Some of the things that we try to do with the HMI or in our SCADA system and the data that we're getting is, if you notice, I have the little eyes up there. And so those little eyes are just standing for information. So one of the things that our old system had is we had everything just piled on one screen. And then there was so much stuff on one screen, you couldn't tell what it was. And it's because everybody thought that you need to have all that data right in front of you all at one time. And so what we're doing is trying to just give just the data that the operator needs to know that he's at a normal situation. And as we have an event, or if we need to know more information, you can hover over the eye and it can bring up all sorts of information. It could tell you your set points, it could tell you the prints that it's located on, it can tell you the floor that it's at, or the other devices that are associated with that system. And so by providing the eye, we're trying to limit the stuff that you see at one moment, but have it available at your mouse tip, so to speak. So as we also talk about our visualization, this is our lower guide bearing. And as you can see, this is a picture of our lower guide bearing. So given the graphics of like, how do you let the operator know what's going on the inside when you can't really see stuff? Not only just applying just the actual real-time value, but giving them an idea of how it's actually working inside. And then also, as you see, we have an eye down there, so we have extra information for the operator if he needs it. So as this works, the operator can look at these things and see that things are running normal. He could see just even by walking, it's very familiar to him about what he's looking at. One of the other projects that we just got done doing that was a little different than our Annunciation was we did a head cover project. And as you can see, this is what the head cover looks like. And if you want to get into it, you're going to probably need about 6 10-ton chain falls to pull that cover off. And so it's really hard for the operators to go in there and look. So by giving a graphic of how it actually works internally and incorporating all the relevant information on one screen that they need just to know that it's running at an optimal condition. And here we have a few more eyes. So like the eyes would tell you exactly how the PLC is working. It would tell you how that the VFD is working if it's running like it's supposed to. It would have that extra information that you might want to look at occasionally, but not necessarily need to in a normal situation. So we're still, like I said, we're still early in our process of moving through the integration process. There's a couple things that even though we're an islanded network within our facility, we still have hopes to take all those end devices and all that data that we're getting and apply that to our maintenance and also apply that further up the chain to the top. There's a few things that we're looking at like MQTT. And especially OEE is another aspect of bringing some of that data to understanding how we could be better with our equipment. Thank you.